All right, everyone. So welcome back to day 3. So please don't hesitate to give me any feedback on any of these videos or how you're turning in work. I think so far, no one. I had one student come talk to me and they said the videos were okay. I think my own personal feedback, something I'm going to try to do better, is be um, more specific about what I need you guys to be doing each day. There's some confusion about the unit circle worksheet. There are some problems at the bottom, like sine of pi over 4 and all that kind of stuff. I did not want you to do that. We did not do them in the video together, but I did not say, hey, don't do these. So I'm going to try to be more specific about doing that. And then please don't forget, every day 2 to 5, I'm available. Wednesday all day, I'm available. But unless you are really just dropping the ball, I'm probably not going to reach out to you and see if you need extra help. But I'd love to help you. So please don't hesitate to reach out. I'm definitely here for you. Okay, so today we're going to be trying to figure out how to do worksheet 3, which says drawing angles practice. We're going to try to figure out the front and the back. So we're going to start with just some notes here. So if you're taking notes, we got to figure out how to draw angles, and then we have a lot of vocab that kind of goes along with these angles. So right now, here's where you should be. You should have your unit circle filled out with all your angles, and we should be pretty comfortable with the ability to draw a blank. If I just give you a blank unit circle, you can fill in all those angles. And eventually, where we really need to be is when I say 5 pi over 3, you already know in your head that's in the 4th quadrant. You just know, okay? Or if I say 3 pi over 4, you already know 2nd quadrant. That's where we need to be eventually, is we need to be so comfortable with those angles that we just know them without having to look at a unit circle or even draw a unit circle. We just have to know, okay? So that's where we need to be soon. And I think if as long as you're working every day on that, you'll get there. Maybe every now and then, if you're bored, just draw a quick circle and fill in your angles real quick. And I think that's a great way to kind of practice and make sure that you're where you need to be. Okay, so enough of that. Let's get down to it. So drawing angles, okay? So let's say I want to draw an angle. So first of all, we need to define something that's called standard position, okay? I think we already talked about this a little bit. Maybe, I don't know if I used the phrase standard position, but an angle in standard position, we'll just do an example to show you what it is. Let's draw theta equals 2 pi over 3. So I want to draw this angle in what's called standard position. So in standard position, we're always going to start on the positive x-axis. We already kind of know that. This is called the initial side. Okay, and then we know that we're going to open counterclockwise. So 2 pi over 3, hopefully you know that's 2nd quadrant. It's more than pi over 2, but it's less than pi. So 2 pi over 3 is right there. Okay, now this picture as it sits is not enough. Okay, because in a minute here, even though I just told you that in standard position, we're going to rotate counterclockwise, in a second, we're going to look at what would happen if I rotate the other way. So you have to add one extra feature. You need to put this little arc with an arrow that's showing me which way did I rotate. Okay, that's going to be really important. So if you didn't put that, then and you just had this line, that's not enough for me to know what angle you're talking about. Okay, so this is my angle in standard position. This side right here is called the terminal side. Okay, terminal meaning ending. So the initial side, if it's in standard position, will always be the positive x-axis, and then the terminal side is where's that angle stop. Okay. All right, let's do one more example. So maybe go ahead and pause the video and see if you can draw theta equals 13 pi over 6. Ready, pause. Okay, so 13 pi over 6. So I know I'm going to start on the positive x-axis. That's my initial side. Okay, so 13 pi over 6. A couple ways we can think about this. That's 2. and 1/6 pi, right? 13/6 is 2 1/6. Okay, so 2 pi would be all the way around once, and then I just have to go 1/6 pi, or pi over 6, which is on my unit circle, and I know that's about right there. And so this would be the angle 13 pi over 6. Now again, do you guys see this little loop-de-loop? I need that loop-de-loop, okay? Because if I didn't have the loop-de-loop and I just did this, how do I know if I'm talking about just pi over 6 or am I talking about 13 pi over 6, right? So I need you to show me that I went all the way around once and then I went to pi over 6, and then that's my angle 13 pi over 6. Okay, so these are my angles in standard position. Okay, let's do, I think I have space for one more here. Now let's talk about some negative angles here. So let's draw theta equals negative pi over 4. Okay, so how do we draw negative angles? Well, negative angles, all you're going to do, you're still going to start on your positive x-axis, but instead of opening counterclockwise to draw the negative angle, we're just going to open clockwise. Okay, so when we draw negative angles, this is really going to test your unit circle knowledge, because you have to know how big is pi over 4. Okay, so if you look at your unit circle, you know that pi over 4 is right in between the first, right in the middle of the first quadrant, right? So if this is what positive pi over 4 looks like, then when I go to draw negative pi over 4, I have to open that same amount, but now I'm just opening clockwise. Okay, so here's negative pi over 4, and then again, you got to draw your little arc with the arrow, because that indicates to me, or whoever's looking at your picture, that this is a negative angle. Okay, so as you can see, if I asked you to draw like negative 5 pi over 6, you really need to know in your head what 5 pi over 6 looks like already, so that you can draw the negative version of that. Okay, so the next thing we got to talk about is pretty big deal. So if you walked away to go get some food or something, maybe come on back and focus for a few minutes. So a big topic for the rest of the year are these things called coterminal angles. Okay, see if we can use context clues. Co, meaning they share, right? Co-captain, you share being a captain. Terminal, meaning that ending side, remember that terminal side? So these are two angles that share the terminal side. So two angles, or more, maybe more than two angles that share a terminal side. Okay, so let's start with a nice, neat angle that we're comfortable with. Let's go with theta equals pi over 2. Okay, so first of all, can you go ahead and draw that for me? Okay, so here's pi over 2, right? Coterminal. I need to find angles that start here and end here, but are not the exact same as that angle right there. Can you think of any way to do that? Well, one way is we can start by facing this way, and then we could just rotate the opposite direction. So instead of going counterclockwise, I can go clockwise. Okay? So this red angle, if you can see, I'm going to try to overlap just a little bit. I started facing that way. I rotated this way, and look, they share a terminal side there. So this blue angle, pi over 2, and this red angle are coterminal. They finish at the same spot. Okay? So here's my question is, what is this red angle, theta? What is the measure of that? Okay, so this is where knowing our unit circle angles helps. I went 3/4 of a circle. So if you look at your unit circle, if you go 3/4 of a circle, that's 3 pi over 2, right? Except I went clockwise. So theta would be negative 3 pi over 2. Okay, so pi over 2 and negative 3 pi over 2, those would be coterminal angles because they stop at the same spot. Okay, now what if I wanted to find another positive coterminal angle? How could I start here and end there by rotating counterclockwise without the angle being pi over 2? Any ideas? Well, maybe you thought of just go around the circle twice or 3 times or just 1 extra time. Okay, so let's go ahead and draw that. So I could go start here. I could go all the way around the circle once and then just finish at the same spot. That makes sense, right? Those would be coterminal angles. So now I need to know how big is this angle. Well, all the way around once, that's 2 pi. And then I want an extra pi over 2. So I did 2 pi plus pi over 2. So 2 pi is like 4 pi over 2. 4 pi over 2 plus pi over 2 would be 5 pi over 2. So 5 pi over 2 is coterminal with negative 3 pi over 2 and positive pi over 2. Okay, so these are called coterminal angles, and they're going to be pretty important for everything that we're doing the rest of the year. Let me go ahead and clear the board and we'll do one together. Okay, so I want to draw theta equals 5 pi over 3. I want to find one positive coterminal angle and one negative coterminal angle. Okay, and really, I'd like you to see if you can try it on your own. All right, so let's see how you did. So 5 pi over 3, it's on your unit circle. It's almost 6 pi over 3, right? It's a little less than 6 pi over 3. That'd be 2 pi. So it's going to be in the 4th quadrant here. Okay, so this is 5 pi over 3. Nice job if you got that. So now I need a negative coterminal angle and a positive coterminal angle. Well, let's start with the negative coterminal angle. So negative coterminal angle still has to start here. I can see it, right? I can picture it. It's this blue angle right here. Can you guys picture that? I started here. I opened clockwise, so it's a negative angle, but it's ending at the same spot. That would be coterminal. So now the tricky part is, how do I figure out what that angle measure is, right? So you might just be able to kind of reason through this one. Think about this. If I made it all the way around the circle, how far would that have been if I made it all the way around? That would have been 2 pi, right? But I didn't make it all the way around the circle, right? How far did I go? I made it 5 pi over 3. So in this case, I would subtract 2 pi minus 5 pi over 3 to figure out how much is left over. Okay, so I can get a common denominator, 6 pi over 3 minus 5 pi over 3 equals 1 pi over 3. So that means this angle right here is pi over 3, but which way did I open up? I opened up clockwise, so this would be negative pi over 3. So this is my first coterminal angle. Okay, so some people like to try to memorize, okay, 2 pi minus whatever the angle is, 2 pi plus whatever the angle is. But I just think draw a picture and try to reason through it, right? I know that this was 5 pi over 3. We were 1 pi over 3 away from finishing the circle, but I opened up clockwise, which means that that angle has to be negative. Okay, now what about a positive coterminal angle? Well, we can just maybe use that same strategy as before. We can make a full lap around and then just complete the circle, right? So in this case, 2 pi would be that extra lap plus 5 pi over 3. Just add those together. So what is this? This is 6 pi over 3 plus 5 pi over 3. That'd be 11 pi over 3. Okay, so in this case, my coterminal angles would be 11 pi over 3 and negative pi over 3. And I could have more, right? Can you picture how you would make another one? You would just go around a second time. We could just add another 2 pi to this, or 4 pi, or 6 pi, or 8 pi, however many times we wanted to. What about this? How could you find more of these? Well, I could just go negative 2 pi minus pi over 3. We can go around the circle in the clockwise direction, okay? So we can find however many of these angles that we want, but there's just different strategies. And I think drawing it is the best way to really visualize that. Okay, 2 more things that we got to talk about. The first one is something that you've heard about. Do you guys remember in geometry talking about complementary angles? Does anyone remember those? So in geometry, we said complementary angles are 2 angles that add to be 90 degrees. That's what we said in geometry, okay? Now, we're in pre-calc. We're really trying to focus on radians. So what do you think our definition is now? So complementary angles are going to be 2 angles that add to, so instead of 90 degrees, that would be pi over 2 radians. Okay, so that's complementary angles. And then while we're here, do you guys remember it's this person's cousin? Complementary angles is cousins with supplementary angles. Do you guys remember those? So in geometry, supplementary angles were 2 angles that added to 180. So today we're going to say what? 2 angles that add to pi radians, right? Pi would be the same as 180 degrees, half circle. Okay, so when you're looking at some different problems like this, you might see, we'll just do one example here. I think one will probably be good enough. Find the complement of, I don't know. Oh, hold on. Mrs. Haugie's calling me. All right, sorry about that. Mrs. Haugie didn't have a mask. I had to go give her a mask so she'd come in the room. Mrs. Haugie. All right, so let's find the complement of 7 pi over 15. Okay, so that's not on my unit circle, but it does exist, right? We can have any angle that we want to on the unit circle. It just might not be one that we memorize. So how would we do this? So if there's 2 angles that add to pi over 2, and one of them is 7 pi over 15, how am I going to find the other one? Well, how about this? Let's just subtract pi over 2 minus 7 pi over 15, and then whatever's left over will tell me what that other angle is. All right. Oh, man. So I got to get a common denominator, 30. So is this 15 pi over 30 minus 14 pi over 30? 15 minus 14 is 1, so it'd be pi over 30 would be the complement. Okay, you guys see the strategy there? If they both add pi over 2, and I'll see pi over 2 minus 1, I know. Okay, and then let's find the supplement of 8 pi over 9. Okay, so what's my strategy here? So supplementary angles are 2 angles that add to pi. So I can just do pi minus whatever one I'd have, 8 pi over 9. Get a common denominator, 9 pi over 9 minus 8 pi over 9. Oops, can't write. Equals pi over 9. So pi over 9 would be the complement of 8 pi over 9. Okay, nothing too exciting there, just something that we need to mention. Okay, last thing of the day. Sorry this video is a little lengthy, but a lot of information that we needed to pack in here. So reference angles is the last thing that we need to talk about. Okay, so let me give you the formal definition. A reference angle is an acute angle formed by the terminal side and the x axis. Okay. So go ahead and write that down. An acute angle formed by the terminal side and the x-axis. Now, what the heck does this mean? Well, let's just look at an example. Let's look at theta equals 5 pi over 6. Okay. So first of all, can you draw that for me? Ready, go. Okay, there's pi over 6. Okay, second quadrant. So let's look at the definition. An acute angle, so that means less than, well, it used to mean less than 90, now it means less than pi over 2. So it's an acute angle formed by the terminal side, which is this side, and the x-axis here. So this angle right here, this is the reference angle. Okay, now what do you notice about this angle? Is this angle in standard position? No, it's not. Okay, also, the fact that it's an acute angle means that it's always going to be positive. So we don't have negative reference angles. They're always positive. Okay, so I want to know what is the measurement of this reference angle. Okay, any ideas how to find that? Well, let's think. If I would have started here and gone all the way to here, that would have been pi radians, but I didn't make it, right? I fell short. So I need to figure out how much is left over. So you might just be able to look at this number and figure it out, but really what I'm going to do here is pi minus 5 pi over 6. Okay, common denominator, 6 pi over 6 minus 5 pi over 6 equals pi over 6. So pi over 6 is my reference angle there. Okay. All right, let's try another one. What about theta equals, which ones did I give you on the homework? Maybe I'll try to avoid those. Theta equals negative 5 pi over 3. Okay. Well, the first thing is you really need to be able to draw this. Okay, so take a look at your unit circle if you have to. So usually 5 pi over 3 is all the way around and it ends up here in the fourth quadrant. But now I'm drawing the negative version of that, right? So negative 5 pi over 3, that's going to be up here. Okay, so here's negative 5 pi over 3. So the reference angle, can you picture where the reference angle is? Can you picture it? So it's the terminal side and the x-axis. So that's this angle right here is my reference angle. Okay. All right. So how do I find that one? Well, you can't just memorize a formula, right? Over here we did pi minus 5 pi over 6. That wouldn't make any sense for this angle. So what am I going to do here? So all the way around would have been 2 pi, but I didn't make it. I fell short. So how much did I fall short? So to find this, I would do 2 pi would be the full circle minus 5 pi over 3, and that's going to tell me what's left over. That's 6 pi over 3 minus 5 pi over 3 would be 1 pi over 3. And remember, reference angles are always positive, so that angle right there would just be 5 pi over 3, and that'd be my reference angle. Okay, so here's my advice on drawing the angles, reference angles, coterminal angles. Don't try to do it in your head. Okay, it's just not worth it. You need to be able to visualize what's happening. Draw these angles, sketch them so you can see what's going on, and then try really hard, just try to use common sense, right? Don't try to memorize formulas, 2 pi minus, 2 pi plus, pi minus, pi. Don't memorize strategies. Just use sense, right? If I almost made it all the way around the circle, that would have been 2 pi. I'll subtract how far I went, see what's left over. So try not to, fall into the habit of, oh, I see a pattern, it'll work every time, because it's not. We have negative angles sometimes, we have positive angles sometimes, so we can't use the same strategy. Okay, so I need you to do this worksheet for me. Okay, I know it's kind of a lot of work today. Tomorrow will probably be a little bit of a lighter day, but trying to keep the pace here. Let me know if you need me. I'm here to help.